Okay, so we have heard from Jason about the president's vision and the role of the regional hubs that have been set up. So there have been several different hubs set up. Today, in our next two panels, we're going to focus on the ones that have been set up in Youngstown, which is focusing on additive manufacturing, and Chicago, which is doing innovation in terms of digital design. And so Youngstown is an interesting area. As a native Buckeye, I remember the ups and downs of that city and that part of the world over the last several decades. The decades of the 1970s and 80s were tough times. We heard a lot about deindustrialization, the Rust Belt, the loss of manufacturing jobs, and Youngstown was one of the epicenters of that decline. But in recent decades, there has been a resurgence there, and manufacturing has started to come back. So we have two individuals who've been very actively involved in Youngstown and in the hub devoted to additive manufacturing and 3D printing. We have Mike Garvey with us. He is the president and CEO of M7 Technologies. And he actually worked on Wall Street before returning to Ohio in 1985 to help his father rebuild the family's manufacturing business. And he helped transform what then was a struggling business into a high-tech precision measurement and manufacturing company. And the company is now collaborating with Youngstown State University to develop digitally based multi-sensor components for the Department of Defense. And then we also have Ed Morris here with us. He is the director of the National Additive Manufacturing Institute, which now is known as America Makes. He also serves as vice president of the National Center for Defense Manufacturing and Machining. Previously, he was the director of mechanical engineering and manufacturing on the Lockheed Martin Corporate Engineering and Technology team. He also has served as a chairman of the National Defense Industrial Association's manufacturing division. And he has more than 40 years of defense, commercial, and international aerospace experience with an emphasis on program management, engineering, procurement, and manufacturing. So what we want to do in this session is kind of dive more into the details, get a little more granular about these hubs, how they're operating, what works, what doesn't work, what are the lessons for other communities. So Mike, I want to start with you. So you helped to transform a struggling manufacturing business into a profitable one. What did you do, and how has the Youngstown Hub been helpful in your particular area?
Sure. Thank you, Daryl. And thank you to the entire John White family for sponsoring this forum. It's very nice of you to bring such attention and focus to these pressing issues. Getting back to M7 Technologies, I returned to Ohio in 1985 with a struggling business. My father and my grandfather's business was a bronze foundry. So if you're familiar with that, that was probably one of the original types of 3D manufacturing going back to the Egyptian age. And in fact, that was my grandfather saying that things haven't changed much in the last 2,000 years, and he didn't think things were going to change much in his lifespan. Well, lo and behold, his namesake was left to clean up some of those post-industrial things. So growing up in Ohio, we were raised at a dinner table, myself, my brother, and my sisters, on appreciation for quality and customer satisfaction. So we set out to rebuild the company to leverage both advanced hardware and software and creating a world-class workforce to get best-in-class customer satisfaction. And the technology we decided to base our business model on was advanced digital measurement. And as a result of that decision, we have significantly changed our business model, improved our profitability, increased our staff education levels significantly, and along with that, the wage at M7. But so in the last 30-ish years, we have grown our family business from when I arrived at an average annual rate of 18% consecutively for the last 30 years.
Impressive. So Ed, you run America Makes. Maybe you could start just by telling us about that organization, what it does, and how it's trying to contribute to the innovation culture of a Rust Belt city.
Good, thanks, Darrell. Well, the National Additive Manufacturing Innovation Institute is also named America Makes. We did a little bit of rebranding. There's some individuals and organizations that are a little fearful when they hear about an institute. So we want to be a little bit user-friendly, particularly to the maker community. So we are America Makes, and sort of a byword in that, when America makes, we believe America works. But we are still very much the National Additive Manufacturing Innovation Institute, focused on accelerating the use of additive manufacturing, or 3D printing, as is popularly known in the press and the media, for the specific purpose of fostering new innovative products. Those new innovative products result in new jobs and boost the fundamental economic activity in the United States, specifically in manufacturing. In that process of being an accelerator for additive manufacturing, the technology itself has been growing quite rapidly. Over the past 25 years, the compound annual growth rate has been on the order of 27%. Over the last 3 years, it's almost 35% CAGR. But we want to accelerate that even faster, specifically for the benefit of the United States. Now, turning to innovation, the technology itself with 3D printing allows you to do designs and manufacturing of products that, by definition, are innovative because they can't be done any other way. But I also want to violently agree with Jason. This is a complementary technology, not a replacement technology. They all fit very nicely together, and when you grow 3D printing, you grow the overall manufacturing economy. Regarding Youngstown, National Center for Defense Manufacturing Machining, which is the organization that operates America Makes, is based in Blairsville, Pennsylvania. How did we get it in Youngstown? The community just has incredible energy. Manufacturing is in their DNA. When we were looking for the right place to be, there was, as President Obama has announced in the past State of the Union address, an abandoned furniture warehouse in downtown was refurbished with the help of the local community, I believe, in 37 days from the time the site was selected until we were putting industrial 3D printing equipment in the building to get us underway. So that's a quick synopsis of who we are, trying to accelerate the use of this technology for the U.S. economy.
So Mike, it seems like one of the virtues of these hubs, not just in Youngstown, but the other ones that have been created, has been their collaborative nature, bringing together universities, business firms, innovators of various sorts. So can you tell us a little bit about how this played out in your particular firm, what kind of resources were made available, and how that helped you build your business?
Sure. So in creating the business model to transition from foundry technology to advanced digital manufacturing technology, that was based on sustainability. And the collaborative nature of this institute brings together over 100, would we have over 100?
102 as of last week.
Yeah, 102 members of the institute, all paying somewhere between $15,000 to $200,000 of annual dues, and being able to participate in research calls to move technology from the technology readiness levels of 1 to 3, which is basically lab environment, proof of concept, through technology levels 4 to 7, which are levels of taking it from a working model in the lab to a working model in the operating environment. So we have been able to participate with different project calls at America Makes with companies such as Lockheed Martin and Northrop Grumman and Ingersoll Machine Tool to apply our manufacturing technology that we recently developed and have patents pending on. And so it's an early stage technology that we're able to combine to help mature our technology while maturing the additive manufacturing technology. We have over 25 projects active right now at America Makes, and totaling over $100 million total of of committed resources to these development projects.
Okay, so Ed, you were mentioning the additive manufacturing component and 3D printing, and we see lots of hype kind of surrounding this in terms of the potential. What do you see as the real contributions in terms of advanced manufacturing and how that's going to contribute to rebuilding economic prosperity?
Well, the amazing thing about 3D printing is the ability to do configurations that, again, you can't do with classical manufacturing. You can make very lightweight structures that are artistic in appearance. In a lot of our classical design, because of the constraints of physical machining, there's limits on the shape in the investment you want to put in time to machine away unneeded material, particularly from mechanical parts. When you're depositing material, you can be very efficient in that material, particularly important if it's very high cost materials such as titanium. You can get the same, or in many cases, improved performance and incredible reductions in cycle time. One of the activities that we're funding through our research and development is based in the Youngstown area, working with local casting foundries. The lead for this research and development is the Youngstown Business Incubator, working very close relationship with Youngstown State University as a community activity in our region, with the objective of taking the time it takes to make the forms for doing classical casting foundry work from months to a week. That's an incredible reduction in cycle time, with the ability to improve the casting performance, with the ability to do the 3D printing of the forms. When you talk about those sorts of cycle time reductions and improved performance, you're also taking out cost. In classical manufacturing communities, we talk about cost, performance, and schedule, and the general sense in the United States is pick any two. And with 3D printing, you can get all three. And that changes the game. One of the reasons I'm comfortable in saying that 3D printing, even with all the hype, is really a game changer in advanced manufacturing, is because it has a whole new set of rules. And when you change the rules, you change the game.
Okay. So Mike, you have moved into advanced digital measurement, and Ed was just talking about 3D printing. So in our earlier Q&A with Jason, Antoine asked a very interesting question. He's also a Brookings trustee, about the development of brain hubs. So it sounds like each of you, because you're moving into more advanced manufacturing, this certainly has ramifications in terms of workforce development, education needs, and kind of the role of the community colleges in those particular areas. So could each of you talk a little bit about the education component, the workforce implications, and what you're looking for now that maybe you wouldn't have been looking for 20 years ago?
Okay, first of all, I would like to address Antoine's question earlier about the lack of development in these Rust Belt cities, because I don't think that there's another city in the nation other than more so than Youngstown, Ohio, that has that designation. And what we have to remember is the prosperity of Youngstown was based on world-class engineering. And with the deindustrialization of that area of the country, that world-class engineering remained present in our DNA. Even though the heavy industrial manufacturing declined, we still had thousands of children that were raised at dinner tables talking about complex engineering, having complex engineering discussions, whether it's materials engineering, it's form or shaping engineering, it's application engineering. And so when the decline happened in Youngstown, there was a mass emigration. And, but there was still a state university that was there that had departments that were built as a result of the companies that had been located there. So there was still a resident knowledge there in these, and I believe they're still there in other Rust Belt cities such as Allentown and Pittsburgh and Cleveland and things like that are considered to be part of the Rust Belt. Now, transitioning those skill sets and talents and criteria, curriculum from whether it's chemical engineering for steel manufacturing or mechanical engineering for forming steel or things like that, they're still math-based, they're still science-based, they're engineering-based talents. And it is a progression, natural progression of those skill sets. So I think that it is an evolution of the skill sets, and that's the great thing about these institutes and that I'm seeing in Youngstown is we have the opportunity to evolve the skill sets that at one time 100 years ago were considered world-class and had gone kind of dormant. Now there's a reawakening of those skill sets in the community and in the college, and the curriculum is being developed around those skill sets. So advanced digital measurement is based on advanced statistical modeling, which has a lot of application in some of these advanced technologies such as 3D printing and lightweight materials, gap band electronics, and digital manufacturing.
Ed, your view on the new skill sets that are needed in advanced manufacturing?
Well, I like very much the way Mike began with his response, and let me go from there and set a foundation in terms of definition of manufacturing that is very germane to the National Additive Manufacturing Innovation Institute. Most folks in the United States, when they hear the word manufacturing, think of production, and incidentally, dirty, dumb, and dangerous, which is incorrect. When we think of manufacturing, and particularly in the context of advanced manufacturing, it's everything you do to conceive, design, produce, test, field, support, and ultimately dispose a product. That's what manufacturing companies do. And we use the phrase big M manufacturing to get the right perspective, the right context. In the area of additive manufacturing and 3D printing, workforce and educational development, one would think that there's a growing fast demand for technicians to run the equipment. And there is a growing demand there, but the real the blockage that we have to get to the tipping point for ubiquitous use of 3D printing, particularly in the United States, is not a shortage of technicians. It's retraining the design engineers to design to this new capability. And a new capability that you can use polymers or plastics, you can use metals, you can make electronic parts, you can make mechanical parts, you can make electronic parts, you can also print with organic tissue for food, and you can print with human tissue, with body parts. So the trade space is enormous, and the initial workforce education has to begin up front with the engineering community. But it goes all the way through the transition. At the feeder stock to the reestablishing the strength, the historic strength of engineering in the United States is obviously with STEM, science, technology, engineering, and mathematics. And by the way, I like to add art to that, STEAM. Because if you're going to start to use 3D printing technology, you need to think a little bit artistic and a little less orthogonal X, Y, Z. And a piece that excited us as we were wrestling with our charter to do workforce and educational outreach, specifically in additive manufacturing, 3D printing, was the aha moment that you can use 3D printing to teach. You can make STEAM, you can make mathematics fun. After all, when you do 3D printing, you're using mathematics in 3D. So if you're having trouble, perhaps as an algebra student in 8th grade, print an algorithm and see what it looks like. And suddenly mathematics becomes real, something that you can relate to. One of the things that I find exciting with the technology in the youth of America, to reinvigorate the interest and the career path sense that this is a valuable and very rewarding field. Brett Lambert, one of my friends, was in leading manufacturing industrial-based policy in the Department of Defense, bought a 3D printer for his girls, two twin girls. And they started shifting away in their activities on Saturday morning to doing design and manufacturing of jewelry, which they would then sell in their school on Monday. Think about it.
That's entrepreneurial talent. I like that.
Who needs a paper route when you have 3D printing?
So that's real STEM education, where they're learning to do the design, the manufacturing, the marketing, the selling, the holistic approach. Reestablishing the fundamentals of manufacturing as a driver, a positive, strong driver in the economy of the United States through this technology. That excites us. At the university level, we've had some conversation with universities talking about, well, I want to start a degree program, bachelor's or master's in additive manufacturing. And I appreciate their intent, but I very pleasantly, as I can, please don't do that. Please embed additive manufacturing, 3D printing in all of your curricula. It's important for mechanical engineers. It's important for electronic engineers. It's important for manufacturing engineers. It's important for the business school. It's important for the medical community. Put it throughout what you're doing. That's the power of what we're doing with 3D printing in the United States.
So Mike, sticking with this education theme, so you've worked closely with Youngstown State University. So could you describe that relationship, what they do for you, how you collaborate with them? Have you seen them make changes in their curriculum in response to your needs?
Oh, absolutely. Our relationship with Youngstown State goes back about 10 years when we established M7 in Youngstown in 2004. And the resources that Youngstown State is able to bring to the table are the lab resources, which are the X-ray photometers and high resolution electron microscopes to look at the materials that are produced and to qualify truth in our measurements. They have also begun to customize some of their graduate programs to more address some of the identified challenges moving forward. And one of those challenges that we see moving forward, we were talking earlier about localized manufacturing, and I couldn't agree with that concept more. My vision of manufacturing in the next 50 to 100 years, it will become localized. It will become massively customized. It will address the cultural desires of that particular geographic region, whether if it's South Florida, Chicago, the Northeast. There's some particular cultural desires, whether it's weather-driven or ethnicity-driven or whatever. So to help address those opportunities in the future, there has to be a curriculum developed so that you understand how to manufacture into those cultural desires. And we're getting back to heavy math and statistical processing. So that's exactly where Youngstown State has answered the bell.
So Ed, are we going to see like a southern version of additive manufacturing that's different from the Midwestern version, which is different from the California brand?
Excellent question. We are the National Additive Manufacturing Innovation Institute. We're located in the Ohio Tech Belt region and proud to be there. As we do things in our region, we want to populate across the United States with our members. With 102 members, we've got a pretty large footprint. On the other hand, as we see activities in 3D printing, additive manufacturing in other areas of the nation, we want to cross-pollinate and bring them back into the Youngstown area. I want to expand a little bit in terms of the concept of hubs and geography and regions. Jason touched on this, but I think maybe it's just a little bit more of a foot stomper, if you will. Geography matters. That's why regional hubs make sense. And why it matters is when you disconnect the design engineer from the shop floor, you're starving that engineer from the fertilizer of innovation. That feedback from the shop floor drives new products, innovative products, evolving products. So it's crucial that we reconnect the design engineer to the shop floor. As we've gone through this offshoring, outsourcing, and so forth, with some business backgrounds and reasons to do that, but the unintended consequences, you disconnected the engineer from the manufacturing floor. And in a lot of cases, they don't even know where it's made. And that's crucial to reconnect that so that you can design it, get the feedback, you can evolve design. That leads to more innovation. So that this geography thing does make a difference. The relationship with the colleges and rapid response to the needs of the local industry. We talk about integrated supply chains. And certainly you can have long-distance integrated supply chains, but it's harder because geography makes a difference. And as I was thinking about that last night, I was thinking about the word, in some cases, what I'm seeing, and particularly with this disconnect for the fertilizer for innovation, with the feedback from the shop floor, it's almost like it's disintegrated supply chains. So the hub region and drawing it to local communities and then proliferating that across the United States with a strong footprint on manufacturing throughout the United States, I think makes a lot of sense.
Okay, I want to close with one last question, then we'll open the floor to any questions from you. And the question for each of you is, I know we're early in this concept of regional manufacturing hubs, but just based on your experience so far, what are the lessons for the other hubs, for other communities that might want to develop a hub? You know, what's worked, what hasn't worked, are there things you would do differently based on what you've seen so far?
Be prepared to move fast. It's a new company startup as a practical matter. We are in the business of collaborating and connecting the dots. And it's certainly a very difficult challenge to support, to sort out with all of the pent-up demand that's coming at us. Who and when to spend time with. Those that are curious versus those that are serious, and being able to understand which is which, and properly invest our public and private funds to accelerate with those that really want to make a change in how they do business using this technology.
Yeah, and I think that one of the biggest successes of the Youngstown Hub, and when I say Youngstown Hub, I mean to say the Tech Belt Hub, which encompasses from Cleveland to Pittsburgh. Youngstown just happens to be geographically right in the center of that corridor, is the attracting private investment. So we are in the process right now of architecting and building a 21st century business park that will co-locate the value chain suppliers of three-dimensional printing, 3D printing, and so that we can compress the technology intersection between the different contributing technologies that result in a final product of 3D printing. So whether it's the design, the equipment manufacturers, the material manufacturers, the application engineers, the commercialization, the distribution, we will be building this park in Youngstown with about 15 innovation centers populated primarily by Fortune 500 companies, that each center will have approximately 100 employees. And when you do the math and think about just the payroll taxes that will result in this development, there's about a 6-to-1 payback in 1 year of the federal investment that went into establishing the center, that is now attracting private investment that realize that they need to become involved in an industry that is growing at the rate of 25 to 35% a year for the next foreseeable 10 years. So that's substantial growth, and it is going to allow the United States to retain what Ed was talking about, the fertilizer to innovation, where we'll have the design, the manufacturing, and the commercialization innovation centers all co-located. So location does matter, geography does matter, and this is a natural evolution to Michael Porter's cluster technology, cluster theory, and this is just the natural growth. So we're very excited to be the test kitchen in this arrangement for the federal government, and we take that responsibility seriously, and we're going to make these things happen.
That's good, because all eyes are on Ohio. Let's open the floor to questions. If you can give us your name and your organization. Is this a question? Yeah, we have a question over here. And I'd also like to remind our webcast audience that we have a Twitter hashtag, USMFG. So if you have a question, you can submit a question through that Twitter hashtag, and we'll integrate your question.
James Sang, IBM retired. About 5 weeks ago in this room, AICGS, and I think you guys, or maybe one of the other people, had a program on German models. And mainly the emphasis was on apprenticeships, but it included it also discussed other things like the Fraunhofer Institutes.
This is German models of manufacturing.
Manufacturing, yeah. And And so I was wondering if you would like to contrast the manufacturing hub approaches as we've developed them with the Fraunhofers, which have a somewhat more broad, general starting point from origin and spreading out through the country, and how you would compare the two models. And also in general, what your comments on German models for manufacturing models for support of SMEs.
So being an SME, I mean, we have a very small company. We're 35 employees. And being familiar with the Fraunhofer model. The Fraunhofer model really takes technology development from very early stage, which would be TRL levels 1, all the way through TRL levels 10. Okay, so typically in this country, TRL levels 1 to 3, which is lab type to proof of concept, are executed in the universities, in the research universities. There was the big gap between 4 to 7, which is the valley of death, which takes that technology to operating environments, and that's the space that the manufacturing institutes occupy. That's the real estate that the manufacturing institutes, and then the technology levels 8 to 10. That will be the space that this private investment will occupy. So, Ed, would you like to?
So I don't pretend to be an expert on the Fraunhofer Institute. I know it was well studied as the vectors were put in place to establish these manufacturing innovation institutes. I've become a champion of public-private partnerships. I think they make sense. Obviously, if we're going to cross the valley of death between research and true product deployment applications, you've got to begin with a public-private partnership that's going to embrace the universities, embrace the industries. We do a lot of activity in our Additive Manufacturing Innovation Institute on road mapping. What direction does industry need to go for their future products? Involve academia on what research they are doing that feeds the roadmap and cause that to all come together, all with the purpose of accelerating the process of getting across that valley of death. I believe that the public-private partnership is the best way to do that. I've been asked some pointed questions. Why public money? Surely industry will put enough funds and invest in this to get us where we need to go in the United States. And each time I've been asked that, I totally look back at the person and say, well, you're right. Industry will ultimately invest and get us where we need to be. However, other nation states are investing substantively in this technology and other advanced manufacturing technologies. And if we want to finish last, then we can do it just industry. But if we want to finish first, we're going to have to do a public-private partnership with investments in this specific technology on par with other nations across the globe. We are in a global competitive economy, and we need to remember that.
And we're also subject to, the larger companies are subject to shareholder requirements. And a lot of decisions have become very short-term based decisions as far as the development goes. And as a result, a lot of these great technologies that have been developed in the universities are kind of the baby that's been left at the door. So with this public-private partnership and the seed funding that goes along with these institutes, we're able to take that to the commercialization level, and that's the whale in this whole model, is creating the jobs from the commercialization of this. So they become spawning pools for jobs.
Okay, other questions? Antoine has another question. We have a microphone coming up from back.
Hi, Ed. I visited you just about a year ago when you were just starting at NAMI. And at that point, you talked about some issues that you needed to resolve in additive manufacturing. Things like the kinds of material you could use, the fusion of materials, the post-process inspection, the size, etc. So a year later, tell us about how you view those issues now and what you feel NAMI has been able to do to get over some of these issues.
Sure. So first I'll comment very politely that we killed the acronym and we're America Makes and not an acronym, just to be friendly with our community. The problems and challenges to use 3D printing are not inconsequential, which is one of the reasons we exist. to identify those technical barriers. How do we understand and are confident that the product that is delivered at the end of the manufacturing process is what we designed for? So there's engineering analysis capabilities that we're working on, materials characterization so that the engineers doing the design have the right material properties as they do their analysis and configuration. Rigorous process control, because when you're doing 3D printing and you're creating internal structure that you can't look at after you're finished, is something that we're focusing on for non-destructive evaluation and non-destructive inspection and so forth. So there's, as you pointed out, there's lots of things to be dealt with to achieve the full capabilities of 3D printing. We're not there yet. Nobody on the planet is. To that end, we are investing research and development projects. The first 7 contract awards are coming closer to finish, and we're starting to see some good results out of that and sharing that within our members. And when we do these research and development projects, it's a combination of the public money with at least $1 per dollar cost share of private funds. So it is truly a public-private partnership to accelerate the solutions to these issues that we're dealing with. That seems to be working well. We've done a second project call. We're in the process of updating roadmaps and investment plans, strategic investment plans, for the next project call. Right now, we have a portfolio of about 25 different projects and growing. And we're also starting to take on what we're calling agency-driven projects, where they have very specific things that they want to address, in addition to the public-private investments that we're making. It seems to be working well. We've got a lot to do, but we're picking up steam.
Other questions? In the back in the corner.
Hi, I'm Jack Bagley, a consultant, and had a small role in the strategy that led to your success on behalf of Case Western. But my question is, how do you deal with IP issues when you have public money, private money, and you're trying to create technology that you can't figure out where the money came from?
Very carefully. It begins with our membership agreement and the construct we have in place for intellectual property as it's developed. A fundamental with regard to National Center for Defense Manufacturing Machining and our business model for operation, we're in the business of solving technical problems for clients. We do not retain intellectual property. The intellectual property resides appropriately with the companies that are using the technology for new products and ongoing products. To that end, when we begin a new research and development project, we require the project team to be very deliberate in declaring any pre-existing intellectual property that is required for that research and development. If there's no pre-existing intellectual property required, then they stay silent and hold it appropriately. As a project team moves on through their activities and they develop intellectual property, that intellectual property is owned by the team, and the team manages the exact ownership within that. Then the balance of our approach to intellectual property within our consortium of America Makes is the requirement that they share the intellectual property with the balance of the members at a fee. And that's so far working well. The classic observation I make with regard to intellectual property, everybody's an expert and almost nobody's an expert. And we've found that it's important to have some really strong rigor in the management of intellectual property, so we're in the process of finalizing a very detailed document with as many details as we can put into it. Good question. It's always a sensitive topic.
Christine has a question from one of our webcast viewers. So if we can get a microphone up here. Thank you.
Thank you. Bob Potter from Washington State asks, what role do you see workforce investment boards, local public employment, and training programs playing in manufacturing communities and also the hubs?
Well, I can answer that since I'm on the local workforce, formerly on the local workforce investment board and the governor's workforce policy board. It's a very critical role and to help in working with the Secondary schools, the high schools, the trade schools, the career centers, and developing the skill sets that can then be leveraged into these more advanced technologies. So it's just a matter of creating a continuum in the curriculum that's starting in the grade schools and then continuing through the high schools and continuing into the community colleges and continuing into the undergraduate degrees, to the graduate degrees, to the postgraduate degrees.
This gentleman here has a question with his hand up. There's a microphone coming over to you.
Sure. James Benton. Excuse me. James Benton.
I know this is an emotional subject for you.
No.
So.
I just have
I get choked up too.
Very catchy voice to me. James Benton, I'm from Georgetown University. And my question relates somewhat to the question that the person just submitted online. I'm concerned about how retraining programs are working, not just from people who are coming through the educational system, but displaced manufacturing workers and other populations that have been shut out or locked out of industries. And to that extent, my question is, what are some of the challenges that these workforce development programs face in getting the displaced manufacturing worker and other target populations who are out there who might have the education but not necessarily the experience to get into industries like these?
It's a great question for Youngstown. I assume you have lots of those people there.
Yeah, we do. So one of the greatest challenges are both on the employer side and on the employee side, understanding the requirements and the responsibilities of the positions that are currently open, and actually having an adult moment and realizing, hey, I need to get some training on understanding fundamental math, understanding how fundamental math builds into algebra, builds into geometry, builds into engineering. So that would be one of the most typical, hey, I'm a crane operator, and I'd worked in the steel mills for the last 30 years, and I have 15 years left on my career path, and the steel mill is no longer working, and I left a job that was paying $35 an hour, and I expect to be reemployed at $35 an hour doing software development, but I have no experience or no training in software development. So it's basically having the adult moment and realizing I need to get trained, I need to take this seriously, and if I expect to provide for my family in the fashion that I've provided for them in the past, then I have to take responsibility for this. And equally, the employer needs to create the opportunities for these people in training coming in and have a graduated level as they begin to show experience and competency and levels, then giving them additional responsibilities with additional pay and just building them back up. So it's a slow but gradual pace, but it's a mutual responsibility side thing.
A real delight for me is to get a deeper exposure to the rich resource called community colleges across the United States. Horribly undervalued, tremendous asset. Everything we can do to support their mission, to address your point, I think is a right thing for us to be doing in the United States. They're doing great work and we need to support them.
And what is it that community colleges are offering that four-year colleges and universities are not doing? What's their unique role?
They'll take the students back to the fundamentals so that they're ready for the postdoc mathematics. But if you don't have those fundamentals, you're building on a foundation of sand instead of rock or concrete.
At a third to a quarter of the cost of pursuing the same types of training in a four-year degree organization, university.
Okay, great. Other questions? Yes, up here, up front, there's a question.
Hi, Anil Sarda from NDP Analytics. I was wondering what some of the regulatory or red tape that SMEs are facing specifically as they pertain to advanced manufacturing firms. Are they energy and focused? Are they environmentally focused? So, thanks.
Well, like all manufacturing, just depending on the flavor of manufacturing you're involved in, we have quality standards and requirements to meet in the marketplace, whether it's ISO certification or military spec certification or several certificating bodies. We're very, very interested in creating organizations that are zero landfill organizations, that are energy efficient organizations. We understand that energy is one of the prime components to operating costs, and to remain competitive, we have to reduce our operating costs as best as possible, employing all available technologies for that. We are compliant with the Armed Services Act, where we provide paid leave absence for people in our armed services, whether it's on weekend endeavors or 2-week training courses to remain active and keep a readiness level in our country should we be posed with threat.
Just to expand, there's a flavoring of what Mike was sharing. From my sense with small companies is keeping up with all the rules and regulations and being able to efficiently do them without being an undue administrative burden. It takes cost, it takes people to respond to some of these policies and procedures, and they can be an inhibitor to growth. They drain cash.
They can be an inhibitor to growth, but they also can be looked at as an investment to growth.
Yes, that's good.
So we look at them as investments to growth, and the reason some of these policies are established, and we embrace the philosophical reasons for them and try to execute within those parameters.
Good.
Over here, there's a question.
Cynthia McIntyre with the Council on Competitiveness. Perhaps Mr. Morris could address the issue of the software industry and how it plays into America Makes activities. Are they gravitating to, new modeling, physical-based modeling for additive manufacturing?
Well, Cynthia, to you, I am Ed, okay? We've had a nice long-term relationship in the community. Software, of course, is a very important tool to do the engineering and manufacturing modeling and simulation and analysis. And we're stressing the capabilities of these tools. So we're in conversations and looking for opportunities to advance the capabilities of the tools to support what we're able to do with 3D printing. If you do a lattice structure with microfluidics in it, and you're challenging a finite element analysis and a computational fluid dynamics software tool to analyze all of that, it's a whole new world, and we're stressing them, which is a good thing. And so we want to continue to encourage the software developers for engineering and manufacturing modeling analysis tools to address the specifics of 3D printing. And to that end, we're eager to deeply partner with our sister institute on Digital Design and Manufacturing Innovation Institute.
That's a preview of coming attractions in 5 minutes.
Because there's no doubt that there are things that we have mutual interest, and we want to sort out so that we collaborate and partner on the things that make sense. There'll be some items that they will address and own. There'll be some subset that we'll address and own, and we're eager to partner with them and delighted that they've been established. I think it was a very wise choice on the part of the nation.
Just to follow up on Ed's comments, I think one thing that software addresses that needs to continually be addressed is the size of the files in manufacturing. Okay, so it is not uncommon to have terabytes of information the size of the file. And getting back to the SMEs, some of the challenges the SMEs have in advanced manufacturing and these types of technologies is we need to have a policy for web neutrality. So meaning that it doesn't matter if you're a small guy or a big guy, you're paying the same rate going across that highway with the same amount of data as the big guy. So if we can get to a nation with web neutrality, that will be a significant improvement in the obstacles to innovation improvement, because a lot of these innovations do come from the small companies like at M7, where we believe that the workshop is the cradle of innovation. So we develop our innovations in the workshop and then reduce them to digital files that we need to compress and get across the network.
And with those large files, I assume you are now a big believer in cloud computing.
Oh, yeah.
So there's another aspect of software that merits attention. 50 plus years ago, blueprints, and of course there was espionage and stealing blueprints. Kind of hard to do. With software, internet, cyber war, it ain't that hard, and it's something we have to pay attention, and we are paying attention to. So that the incredible technology, even the CAD files of proprietary designs, are intellectual property that must be protected. And in a cyber warfare, that's something you have to pay attention to.
At the very back, there's someone standing who has a question.
Hi, Jasmine Bridges. I'm an industry fellow at the Department of Energy. And Ed, you said something that is awesome. As a manufacturing person, I know how critical it is to connect the designer back to the shop floor.
Yes.
Can you speak a little bit more about that in terms of this advanced manufacturing landscape? What is your vision? How do you think we continue to make sure the designer is connected to the shop floor, and how that affects current manufacturing and future manufacturing?
Well, again, proximity makes a difference only because of the travel time, travel cost. You can have a really great integrated supplier that's 1,000 miles away, and you just have to endure the business expense of going the face-to-face. After all, technology development, it is a contact sport. It just gets more complex when you're 10,000 miles away versus 1,000 miles away, and certainly it's very convenient when they're 10 miles away. But that face-to-face, then once you've got the rapport and you do the occasional face-to-face, then you can do a lot of, obviously, electronic webinars, so on and so forth, but without even the initial contacts. I've certainly had the opportunity in my past of working with some key suppliers, and I'll walk the shop floor and go over to a machinist and hey, I understand you're from such and such a company. Let me show you how stupid this is. And I'll pick that up and we'll go back and deal with it with the engineering community, but the engineers that did it didn't learn. And it's important that we have that feedback so that we can continue to improve our engineering capabilities. And it's again, a contact sport. Contact sport requires some investment. The electronic medium and teleconferences, even the video, it helps, but it doesn't completely solve the issues of a good learning experience to, again, feed the next product evolutions and so forth and have better design engineers. With the culture of that we're pursuing, like Brett Lambert's children, where they're in this environment where they do the design, they do the manufacturing, they do the inspection, they do the selling. If we get that culture reestablished, if you think you can build it, it'll help, I believe, with the engineers coming up through the ranks to recognize the importance of staying in contact with the manufacturing shop floor.
I'd like to close with one last question for each of you before we move on to our next panel. And that is kind of taking advantage of the fact that we are sitting in Washington, D.C. If each of you could talk to members of Congress and or people in the administration and just offer them advice on how we should be doing this, based on the experience you've had in Youngstown, what would each of you tell them?
I would recommend that they do more of these manufacturing hubs. Absolutely. They pass the legislation, get these hubs funded. I think that, as Jason described very appropriately, that the erosion of the manufacturing base has led to tremendous amounts of social ills. And I've lived through it. I've seen it in Youngstown. And if we can reestablish our prominence in manufacturing, design, engineering, distribution, then we have a greater chance of enjoying prosperity in our country. So I don't understand how anybody could possibly argue with these things.
I don't know. In this town, I believe that's possible.
Yeah.
Ed?
Certainly, we are very pleased to see the leadership in the nation on both sides of the aisle recognize that manufacturing is critical to the future economy of the United States. And the appropriate investments on the public side, partnering with industry, is something that we must continue. We need to judiciously expand it in the right areas. And we, again, are delighted to participate in that discourse. In terms of innovation, one thing I want to further observe, what we're doing in the Innovation Institutes, and certainly with the one that I'm privileged to be associated with America Makes, it's more than innovation on the technology. It's innovation on how you do business. Public partnerships, I've participated in some in the past, and we're trying to really push the edge on how deeply can we partner. To the extent when we're doing research and development projects led by industry or led by a university, but certainly a holistic team of academia, universities, and industry participating, we are embedding some of the agency department employees that are experts in the specifics of a research and development project in the project. That's getting to the true essence of a public-private partnership, and we think we need to continue to do that as a nation.
Terrific. No, that's a great finale there. So I want to thank Ed and Mike for sharing their views with us. Good luck on your future ventures, and we'll look forward to seeing how things develop over the next year or two. Thank you very much.